students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as ionic equilibria. Next, let's see what is ionization of water. Let us see ionization of water. Now, the degree of dissociation of pure water is very small, which is evident from the poor electrical conductivity of water. Therefore, it can be considered that water is a weak electrolyte, right? It's only one molecule out of 55 into 10 raised to 8 molecules that undergoes dissociation, which is a clear enough mathematical proof to tell you that how weak is the degree of dissociation or ionization of water, right? So the water molecule is formed due to hybridization, which contains a lone pair of electron. The bond is formed due to hybridization. It is a highly polar compound. That is the reason why it is so difficult to break that bond. It undergoes self-ionization, right? I can say that degree of dissociation of pure water, degree of dissociation of pure water is very small, right? It is considered as a weak electrolyte, right? And the HOH bond is formed due to sp3 hybridization, and it is a highly polar compound. Right? So as a result of which water reacts with water reversibly to give you hydronium ions plus hydroxyl ion, right? Now in this case, this water molecule, the first water molecule is going to lose a hydrogen. Therefore this will be acid 1 and this is going to be base 1. This water molecule is going to gain a hydrogen to form hydronium. So this is going to be base 2 and acid 2. Fine, do we get this thing clear? Now, this water molecule will lose H2O, will lose one hydrogen to form hydroxyl. The capacity to give a hydrogen is, as per Lewis's theory, is nothing but acid. So this will be acid and this will be its conjugate base. Similarly, this water molecule is going to take in a hydrogen to form hydronium. Therefore, this is going to be base and this is going to be acid. Right?
So, one H from there is going to that base and the other.
This is going to lose one hydrogen. Yeah. Therefore, what I get is its conjugate base. This is the acid. This is the base formed from this acid. Right? Every acid gives rise to its own conjugate base. So this acid is going to give rise to this conjugate base. Similarly, this base will give rise to its conjugate acid. What is conjugate base and acid? Acids and bases that differ from each other by a single hydrogen atom are called as conjugate acids and bases. So this acid will form this particular conjugate base. This base will form this particular conjugate acid.
And where is the third hydrogen coming from?
This hydrogen that is lost is going to react from, right? If you see the number of hydrogen 4 and 4, oxygen 2 and 2, the equation is balanced, right? Now, so in this reaction, one water molecule acts as an acceptor of proton and forms the base, and the other water molecule acts as a donor and acts as an acid, right? I can say that the ionization of water can be written can also be written written as water dissociates reversibly to give you hydrogen ions plus hydroxyl ions, right? Now it has been found out that in 10 raised to 7 liters of water, in 10 raised to 7 liters of pure water at 298 Kelvin, only 1 mole of hydrogen ion and 1 mole of hydroxyl ion is present. Only 1 mole of hydrogen ion and 1 mole of hydroxyl ion is present. Fine, do we get this thing here? Therefore, I can say that the concentration of hydrogen ions, the concentration of hydrogen ion is going to be 1 into 10 raised to minus 7 moles per decimeter cube. So many moles are present in so many decimeter cube of water, decimeter cube. And similarly, I can say that the concentration of hydroxyl ions will be also 1 into 10 raised to minus 7 moles per decimeter cube. Right? Now, once I know the ionization of water, I can therefore find out the ionic product of water. Ionic product of water. Ionic product of water. Now, I can say that the dissociation of water can be represented as dissociation of water can be represented as water molecule dissociates to give you hydrogen ions plus hydroxyl ions, right? Now if I apply law of mass action to this, law of mass action, dissociation constant is active mass of the product upon active mass of the reactant. That's my law of mass action. Now, where K is your equilibrium constant, now if I rearrange, I can say K into H2O is nothing but active mass of hydrogen into active mass of hydroxyl, right? But I can say that the degree, we've already discussed this, that the degree of dissociation of water is very small, but the degree of dissociation of water is very small. Hence, I can say that the concentration of unionized water can be taken as constant. Therefore, concentration of unionized water can be considered constant. If I consider the concentration of unionized water as constant, then I can say that K into constant is equal to hydrogen ion concentration into hydroxyl ion concentration, right? Now this K into constant is called as Kw, which will be your hydrogen ion concentration into hydroxyl ion concentration, right? Where Kw is nothing but it is called as ionic product of water. So ionic product of water is defined as the product of hydrogen ion concentration and hydroxyl ion concentration. So how do I define this? Definition: the product of molar concentration of hydrogen ions and hydroxyl ions in pure water. Hydroxyl ions in pure water at any given temperature is constant. At any given temperature is constant and is called and is known as ionic product of water. right? So do we understand what is ionic product of water, right? Now let's try to find out the numerical value of ionic product of water. We already know that the active mass of hydrogen is 1 into 10 raised to minus 7 moles per decimeter cube, right? We've already derived this. Similarly, the active mass of hydroxyl ions is also equal to 1 into 10 raised to minus 7 moles per decimeter cube, right? In which case, therefore, I can say that ionic product of water, therefore I can say that ionic product of water is 1 into 10 raised to minus 7 into 1 into 10 raised to minus 7. So ionic product of water is 1 into 10 raised to minus 14 moles per decimeter cube. So the ionic product of water is 1 into 10 raised to minus 14 moles per decimeter cube. Fine, do we get this thing clear? Now, let us now find out, I can say in pure water, we know that the hydrogen ion concentration is equal to hydroxyl ion concentration, right? And we also know that Kw we have already derived as 1 into 10 raised to minus 14. Now, from ionic product of water, it is clear that from ionic product of water, it is clear that an aqueous solution will be acidic if hydrogen ion concentration is greater than hydroxyl ion concentration, because in pure water both are equal. Now if the hydrogen ion concentration becomes greater than hydroxyl ion concentration, then the solution will become acidic. Similarly, an aqueous solution will be basic if hydrogen ion concentration is less than hydroxyl ion concentration, right? Now, we know that, therefore I can say that if H plus is 1 into 10 raised to minus 7, then solution is neutral, because then the hydrogen ion concentration will become equal to the hydroxyl ion concentration. If H plus is greater than 1 into 10 raised to minus 7, then the solution will be acidic, right? Similarly, if H plus is less than 1 into 10 raised to minus 7, then the solution will be basic. This leads us to how do you another concept about acidity. How do you find out whether a solution is acidic or basic? Now this was discovered by a scientist called as, we'll discuss the pH scale. This was discovered by the scientist Sorensen in 1909. He came up with a convenient way to find out whether a solution is acidic or basic, right? He said that pH is, he said that there's a convenient way of expressing the hydrogen ion concentration, which he called as pH, where pH scale expresses hydrogen ion concentration, right, where P indicates potence, right, or potential. That is what the P indicates, and H indicates hydrogen ion concentration. So pH indicates the potential of hydrogen ion. Fine, do we get this thing here? Now, let's define pH. Definition wise, how do I define pH? pH is defined as negative log to the base 10 of hydrogen ion concentration. Is defined as negative log to the base 10 of hydrogen ion concentration expressed in moles per decimeter cube. Right? So as per the definition, pH is negative log to the base 10 of hydrogen ion concentration. In order to get rid of the negative sign, how do I get rid of the negative sign? This can be written as log 1 upon H plus to the base 10. That's how you indicate pH. Right? So pH, this is your definition of pH. Similarly, how do I define pOH? Definition of pOH. Right? Now, same way, pOH is defined as negative log to the base 10 of hydroxyl ion concentration. Instead of hydrogen, it will be hydroxyl ion concentration expressed in moles per decimeter cube. pOH is defined as negative log to the base 10 of hydroxyl ion concentration expressed in moles per decimeter cube. Therefore, I can say pOH is negative log to the base 10 of hydroxyl ion concentration. To get rid of the negative sign, I can say 1 upon OH negative to the base 10. Right? Do we get this thing here?
So why no negative sign?
In where? This? To convert negative sign to positive, I am taking that H in the denominator. That's how you convert negative sign to positive in logs. Fine, do we get this thing here? Now, if, let us consider, if, let's assume that hydrogen ion concentration is equal to 1 mole per decimeter cube. If H is 1 mole per decimeter cube, then I can say pH is negative log to the base 10 of 1, because hydrogen ion concentration is 1, and we know that log of 1 is 0. That means the solution will be acidic if pH is 0. Right? Similarly, if OH minus is let's consider if H is 0.1. Before I move on to OH, let's consider if H plus is say 0.1 moles per decimeter cube. Right? In that case, pH will be negative log to the base 10 of 0.1, right? Which is nothing but 0.1 can be written as 1 into 10 raised to minus 1. This can be written as negative log to the base 10, 1 into 10 raised to minus 1. Right? Now, this can be written as negative log to the base 10 of 1 plus negative log to the base 10 of 10 raised to minus 1. Multiplication changes to addition in log. Negative log to the base 10 of 1. Log of 1 is 0. Whatever is the number in the index comes before the log. So this minus into minus will give you plus 1. Log 10 to the base 10. Log 10 to the base 10 is 1. So in that case, if H plus is 0.1, then pH will be equal to 1. Fine, do we get this? Using this, Sorensen came up with a scale called as the pH scale. He said that on the pH scale, he said that if H plus is 0, pH is 0, then the solution is acidic, right? And the solution will be basic when pH is if H plus is -1, then pH comes out to be 1. Now I'll just show you how you come up with this scale. Now from these two equations, it's very clear that pH and pOH are inversely proportional to each other. If pH increases, then pOH has to decrease. If the solution is acidic, it cannot be basic, right? As I go on increasing the acidic level, the basic nature of the solution will go on decreasing, right? So when the concentration of hydrogen ions becomes equal to the concentration of hydroxyl ions, then the solution is going to be neutral, right? So if concentration of H plus is equal to concentration of OH minus, then solution is neutral, right? Now in which case I can say which is possible when H plus is 10 raised to -7, where therefore I can say that at that point of time hydrogen ion concentration is 1 into 10 raised to -7 moles per decimeter cube, and hydroxyl ion concentration will also be 1 into 10 raised to -7 moles per decimeter cube. If I use this in the formula, pH is negative log to the base 10 of hydrogen ion concentration and negative log to the base 10 of hydroxyl ion concentration, I'll get that the solution will be neutral. Solution is neutral when pH is 7 and or pOH is 7. So the solution is neutral when pH is 7 or pOH is 7, right? We have already seen that the solution will be acidic when pH is 0, right? If the concentration, if hydrogen ion concentration becomes greater than 10 raised to -7 moles per decimeter cube, right? Then the solution becomes acidic. Then solution becomes acidic and pH becomes less than 7. Similarly, if hydrogen ion concentration becomes less than 10 raised to -7 moles per decimeter cube, then solution becomes basic. And pH becomes greater than 7, because only hydrogen ion concentration will decrease when the value of pH becomes greater than 7. So on the basis of this, and we know that the total number of moles in water is 1 into 10 raised to -14, we have derived this. The ionic product of water is 1 into 10 raised to -14. Therefore, he came up with a scale stating that pH scale is a set of positive numbers from 0 to 14. pH scale is a set of positive numbers from 0 to 14, where 0 indicates acidic and 14 indicates basic. Where 0 indicates acidic and 14 indicates basic. Right? So do we understand the formation of pH scale? Next, let's derive the relationship between pH and pOH. Derive pH plus pOH is equal to 14. Now we know that for pure water, the ionic product of water is always constant. For pure water, ionic product of water is constant, and we know that ionic product of water H plus into OH minus is 14, 10 raised to minus 14, sorry. Right, the ionic product of water is nothing but 10 raised to minus 14 at 298 Kelvin. Now once I know this, then I can say take log on both sides. If I take log on both sides, I will get log of hydrogen ion concentration into hydroxyl ion concentration is log of 10 raised to minus 14. Right? Multiplication changes to addition and log. So this will be log of, we are taking log to the base 10. Log of hydrogen ion concentration to the base 10 plus log of hydroxyl ion concentration to the base 10 is nothing but minus 14 log 10 to the base 10. Right? Now, I can say that multiply by minus 1. So I'll get negative log to the base 10 of hydrogen ion concentration plus negative log to the base 10 of hydroxyl ion concentration is plus 14. Log 10 to the base 10 is 1. But negative log to the base 10 of hydrogen ion concentration, but by definition we know that negative log to the base 10 of hydrogen ion concentration is pH, and negative log to the base 10 of hydroxyl ion concentration is pOH. Therefore I can say that pH plus pOH is 14. That's how you come up with the derivation that pH plus pOH is 14. Right? Let's see numericals based on this, guys. Take down a numerical. We'll start with numericals based on pH and pOH. Right? Can I have a log book, please? See if you can give me a log book. Right. Okay, in the meantime, guys, take down, please. Calculate, take down the sum, please. Calculate the pH of negative, thank you. Calculate the pH of calculate the pH of 0.02 molar. Calculate the pH of 0.02 molar solution of HCl. Calculate the pH of 0.02 molar solution of HCl. Right? Now, let's see this. I can say HCl dissociates as HCl would dissociate completely to give you hydrogen ion concentration plus negative hydroxyl ion concentration. Concentration of HCl is 0.02. Hence, the hydrogen ion, since it is dissociating completely, the concentration of hydrogen ion will be 0.02 and hydroxyl ions will also be 0.02. That means I can say that hydrogen ion concentration is going to be 0.02. Right? Once I have this, I can find out pH. pH is negative log to the base 10 of hydrogen ion concentration. This is negative log to the base 10 of 0.02. Right? This can be written as negative log to the base 10 of 2 into 10 raised to minus 2. Right? Multiplication changes to addition and log. Multiplication changes to addition and log. So let's change this, guys. This can be written as negative log 10 to the base 2 minus 2 log 10 to the base 10. Right? This can be written as, this is the minus sign in between. This negative log I'm multiplying with both of them. That's how I got the minus sign in between, right? Log 2 to the base 10 is 0.3010. Characteristics is 0. Mantissa is 3010. Minus into minus plus 4. 4 no. This is going to be, sorry, 2. Minus into minus plus 2. Subtract this. When you subtract this, you will get this as 1.6990. So the pH of the solution is 1.6990. Right? Take down another sum, guys, please. Calculate the pH of 0.02 molar. Calculate the pH of 0.02 molar sulfuric acid. Now I can say dissociation of sulfuric acid. Sulfuric acid H2SO4 dissociates completely to give you valency of sulfate is 2. So 2 hydrogen ions plus sulfate minus 2. Right? In that case, if the concentration of sulfuric acid is 0.02, then the concentration of hydrogen will be twice of that, 0.04, and this will be 0.02. Since I am getting 2 hydrogen ions, therefore the concentration of hydrogen ions will be twice the concentration of sulfuric acid. Therefore I can say that hydrogen ion concentration is going to be 0.04. Once you have this, you can see the previous sum and solve this. I am not solving this. I want you all to try this on your own. Right? Look at the previous sum and try solving this on your own. You should get this answer as 1.3939. Next, take on another sum, guys. Find the pH of, you will do that for homework, guys. Take on next sum, please. Find the pH of 0.02 molar hypophosphoric acid. Dissociation of hypophosphoric acid, right? H3PO4 dissociates. It dissociates completely phosphate. The phosphate radical has a valency of 3 minus. So this will be 3 plus H plus PO4 3 minus. If the concentration of this is 0.02 molar, then this is going to be thrice of that, 0.06, and this is going to be 0.02. Therefore I can say that my hydrogen ion concentration is going to be 0.06. Right? Once you have this, look at your first sum, try solving the sum on your own. You should get this answer as 1.2218. Right? Next, take down next sum, please. Take down next sum, please. Calculate the pH of a solution. Calculate the pH of a solution containing 1.12 into 10 raised to minus 2 kgs, 1.12 into 10 raised to minus 2 kgs of KOH in 2 decimeter cube of solution. The molecular weight of KOH is 56. Right? Now they have given you that the solution contains 1.12 into 10 raised to minus 2 kgs of KOH in 2 decimeter cube. The sum says that it contains 1.12 into 10 raised to minus 2 kgs of KOH in 2 decimeter cube. That means how many kgs of KOH will it contain in 1 decimeter cube? X is therefore going to be 1.12 into 10 raised to minus 2 upon 2. That is going to be 0.52 are 10, 56 into 10 raised to minus 2 kgs. So it will contain 0.56 into 10 raised to minus 2 kgs of KOH in 1 decimeter cube. Now, let's find out the number of moles of KOH per decimeter cube. Number of moles of KOH per decimeter cube. How do you find out number of moles? That is the weight upon molecular weight. Weight of the solute divided by molecular weight. Weight of the solute is 0.56 into 10 raised to minus 2 kgs. Molecular weight in the sum is given to you as 56. When nothing is specified, you have to assume the molecular weight in grams. When they say 56, that means the molecular weight is 56 grams. You want to convert it into kilograms, so this will be 56 into 10 raised to minus 3. Right? So when you solve this, you will get this answer as 10 raised to minus 1, which is 0.1. Right? So in that case, I can therefore say the KOH is a strong base. It will dissociate completely to give you K plus OH minus. Right? We just found out that the concentration of KOH is 0.1. Right? Number of moles per decimeter cube is nothing but concentration. So we found out that the concentration of KOH is 0.1. Therefore, concentration of potassium will be 0.1 and hydroxyl ions will also be 0.1. That means I can say that concentration of hydroxyl ions is 0.1. Since I know the concentration of hydroxyl ions, I can find out POH. POH is negative log to the base 10 of OH ions. So this is going to be negative log to the base 10 of 0.1 is 1 into 10 raised to minus 1. Right? Negative log 1 to the base 10 minus 1 log 10 to the base 10. Log 1 is 0, 1 into log 1 is 0, minus into minus plus 1, log 10 to the base 10 is 1. Right? So POH is going to be 1. Once I know POH, then I can find out pH. But we know that pH plus POH is equal to 14. So therefore pH plus 1 is 14. Therefore pH will be equal to 13. So the pH of the solution is 13. Right? Take down another sum, guys. Calculate the hydrogen ion concentration. Calculate the hydrogen ion concentration. Calculate the hydrogen ion concentration of blood serum. Calculate the hydrogen ion concentration of blood serum whose pH is 6.6. Whose pH is 6.6. Now, those of you who've done logs thoroughly should be able to understand it. Those of you who haven't done it, please observe this carefully. Now, pH is defined as negative log to the base 10 of hydrogen ion concentration. pH is given to you as 6.6 is negative log to the base 10 of hydrogen ion concentration. Right? Take log on the other side. Now, first of all, I need to get rid of the minus sign first. So if I get rid of the minus sign, I get negative 6.6 is log H plus to the base 10, right? Take log on the other side. When you take log on the other side, it becomes anti-log. So you will get anti-log of negative 6.6 is H plus, right? Anti-log is to the base 10. Now the problem here, people, is that you cannot find anti-log of a negative number. First thing that you have to do is convert it into a positive number, right? How do I convert this into positive number? This can be written as anti-log to the base 10. Observe carefully. Negative 6.6 can be written as negative 6 and negative 0.6. Negative 6.6 can be written as negative 6. Segregate the real part and the decimal part. Segregate the whole number and the decimal part. Okay. Now, subtract 1, add 1. You always do this. To convert a negative number to positive, you always do this. Subtract 1, add 1. So, if I subtract 1, add 1, this will be h plus, right? So, this is going to be anti-log of negative 7 minus 1 minus 6 is minus 7 plus 1 minus 0.6 is going to give you 0.4 is h plus, right? Minus 7 can be written as 7 bar. While doing logs, the characteristics can be negative, the matrix cannot be negative, right? So this can be written as anti-log of 7 bar 0.4 to the base 10 is hydrogen ion concentration, right? Then you can find out the anti-log of 0.4. The anti-log of 0.4 is going to be 2512. The anti-log of 0.4 is going to be 2512. Whatever is the number before the decimal, add 1 to it. Minus 7 plus 1 is minus 6. That means the decimal has to shift 6 places to the left. Now people, please understand this also. The decimal is here. It has to shift 6 places to the left. Instead of shifting it 6 places to the left, if I shift it 1 place to the right, that means I'll have to multiply by 10 raised to minus 7. This is the actual mathematical logic. Now I'll tell you in the examination, whatever is this number, whatever is your characteristics, write 10 raised to that number. Manthasa, write 2 point. So your hydrogen ion concentration in blood serum is 2.512 into 10 raised to minus 7 moles per decimeter cube. Those are the number of hydrogen ions that are present in blood per decimeter cube. Fine, do we get this thing clear? So do we understand how to convert that negative number? Most of the sum is pretty simple. Most of the students get confused about how to get that negative anti-log. Right? Everyone's followed this? If your basics of 11th are clear, then you won't have a problem, and if you don't, please make sure that you understand this. Right? Take our next sum, please. Calculate the OH ion concentration. Calculate the OH ion concentration of a solution. Calculate the OH ion concentration of a solution whose pH is 5.2. First of all, I can say as pH plus pOH is equal to 14, 5.2 plus pOH will be 14, so pOH is 8.8. Once you have pOH, then exactly like the previous sum where you will get a negative log, and you should be able to solve this. Please see the previous sum and try solving this. I'm directly giving you the answer for this. You should get your hydroxyl ion concentration as 1.585 into 10 raised to minus 9 moles per decimeter cube. Right? Take our next sum, please. The pH of a weak monobasic acid. The pH of a weak monobasic acid is 0.02 mole. Sorry, the pH of a weak monobasic acid in its pH of a weak monobasic acid in its 0.02 molar solution. In its 0.02 molar solution is 3.78. Calculate, I'll repeat the sum, the pH of weak monobasic acid in its 0.02 molar solution is 3.78. Calculate the degree of ionization. Calculate the degree of ionization, the ionization constant, and percentage ionization. Now, since the given acid is a monobasic acid, I can therefore say that pH will be negative log to the base 10 of hydrogen ion concentration. The value of C will not change. That means when it dissociates, whatever is the reactant of the acid, suppose if it was, say, like in the case of HCl, HCl dissociates to give me one hydrogen ion and one chloride ion. That's a monobasic acid. So since this is a monobasic acid, the value of C will not change. Had they given you dibasic, then I would have multiplied C by 2. I would have multiplied the concentration by 2. Okay. Now let's see this. I can therefore say pH is negative log to the base 10 of 0.02. Right? Now let's see this. This can be written as pH is negative log 10, 2 into 10 raised to minus 2. Right? So this can be written as pH is negative log 2 to the base 10 minus 2 log 10 to the base 10, negative log 2 to the base 10. Log 2 to the base 10 is 0.3010, minus into minus plus, and this is going to be 2. Log 10 to the base 10 is 1. Right? Now, when you subtract this, this is going to give you, this is going to give you
1.6990.
1.6990.
990.
This is going to be plus 1.6990. Right? So the pH of the given solution is going to be 1.6990. Right? Now, once I have this, guys, pH is given to you in the sum. pH is given to you as 3.78 is negative log to the base 10 of hydrogen ion concentration. Take minus sign on the other side. Negative log 3.78 is log H plus to the base 10. Take log on the other side. Anti-log of negative 3.78 to the base 10 is hydrogen ion concentration. This can be written as anti-log to the base 10, negative 3, negative 0.78, subtract 1, add 1 is hydrogen ion concentration. So anti-log to the base 10 minus 4 plus 0.22 is hydrogen ion concentration, in which case you will get anti-log to the base 10 4 bar 0.22 is hydrogen ion concentration, right? Now when you take anti-log of this, you should get this answer as 1.660 into 10 raised to minus 4 is hydrogen ion concentration. So once you know the hydrogen ion concentration, then I can say that hydrogen ion concentration is nothing but degree of dissociation into C, right? So in that case, I will get 1.660 into 10 raised to minus 4 is equal to alpha into C is 0.02. That will get me the value of alpha. When you solve this, you get alpha as 8.3 into 10 raised to minus 3. So my degree of dissociation is 8.3 into 10 raised to minus 3. Next, I have to find out dissociation constant. Dissociation constant is nothing but alpha square C, right? So Ka is going to be alpha square 8.3 into 10 raised to minus 3 into C 0.02, right? When you solve this, you will get this as 1.3778 into 10 raised to minus 6, right? So you found out all the three things. You have to find out hydrogen ion concentration, you have to find out degree of dissociation, and you have to find out dissociation constant. Right? Let's move on to the next sum, guys. Take down another sum, please. At 300 Kelvin, a weak monobasic acid is 1.5% ionized. Is 1.5% ionized in 1/100 molar solution. Calculate the hydrogen ion concentration. Calculate the hydrogen ion concentration, the dissociation constant and pH. The dissociation constant and pH. Now let's see this. I can say alpha is equal to they'll give you that alpha is equal to, they'll give you percentage alpha. So percentage alpha upon 100, so that's 1.5 upon 100, that's 1.5 into 10 raised to minus 2. I now know the value of alpha. So that was the first thing I know. They haven't asked you this, right? They've asked you to find out for monobasic acid, they've asked you to find out the hydrogen ion concentration. Hydrogen ion concentration is alpha C. I know alpha, I know C, I should be able to get this. I'm not showing you the calculation, you should be able to get this. Next, they will ask you to find out the dissociation constant is alpha square C. Again I know the value of alpha and I know the value of C. I know the value of alpha, I know the value of C. Hence, I should be able to get the dissociation constant. Next, last thing they've asked you to find out is pH. pH is negative log to the base 10 of hydrogen ion concentration. You've already found out the hydrogen ion concentration from here. So you should be able to get the value of pH. The answers for this, I'm not calculating, I want you to do this on your own. The answers for this is H plus is going to be 1.5 into 10 raised to minus 4 moles per decimeter cube. Then Ka is going to be equal to 2.25 into 10 raised to minus 6 and pH is going to be equal to pH should be equal to 3.823 right? Next, take down next sum please. Calculate pH. of 0.1 molar. Calculate pH of 0.1 molar acetic acid, 0.1 molar acetic acid, which is 1% dissociated, which is 1% dissociated. Replica of the previous sum. They've given you concentration, they've given you degree of dissociation. You can look at the previous sum and get the answer. Here they've asked you only pH, so you should get your answer for pH as 3. Remember, to get pH first you'll have to get the value of H plus. H plus is, you'll have to first get the hydrogen ion concentration. You'll get hydrogen ion concentration by using the formula alpha C, and then use the pH formula to get the answer for pH formula, that is negative log to the base 10 of H plus ion. Take down next one please. The pH of 0.01 molar, the pH of 0.01 molar, the pH of 0.01 molar solution of ammonium hydroxide, 0.01 molar solution of ammonium hydroxide is 11.2. Calculate the degree of dissociation and the dissociation constant of the base. Calculate the degree of dissociation and the dissociation constant of the base. Nice. Base, that means first I need to know pOH. First I'll use the formula pH plus pOH is 14. That will give me the value of pOH. Once I know pOH, the next formula I will use is pOH is negative log to the base 10 of OH ions. That will give me my OH ion concentration. Once I have that, then I can find out the value of alpha, degree of dissociation. I can say that OH ion concentration is nothing but alpha C. C is already given to you, so you will come to know the value of alpha. And last thing they've asked you to find out is dissociation constant, Ka. Ka is nothing but alpha square C. Alpha I know, C I know, I should be able to get the answer. The answer for this sum should be, you should get the value of OH negative as 1.585 into 10 raised to minus 3 moles per decimeter cube. You should get the value of alpha as 0.1585, and you should get the value of dissociation constant of the base as 2.512 into 10 raised to minus 4. Right? Okay, we'll stop this here for the day. Thank you very much.